Hello everyone, I'm Morris Munene. In this session we are going to solve a set of simultaneous equation of three unknown using the cofactor method, and we have a question. Use the cofactor method to solve for value of x, y and z in the following set of simultaneous equation. We have x, y plus z is equals to 6, 2y plus 5z is equals to negative 4, and also we have 2x plus 5y minus z is equals to 27. The first thing that we need to do is to form a matrix from these values. We take the coefficient of x in this first column here, which is 1. In the second equation, the coefficient of x is 0, and in the third column, the coefficient of x is equals to 2, and also in the second row, the coefficients of y is equals to 1, in the second one is equals to 2, and in the third one is equals to 5. And then in the other one, we have the coefficient of x being 1, the coefficient of x being 5, and the coefficient of z being negative 1. And then from here we have the values of x, y, and z. Remember, if we can multiply rows and columns here, we can get the same values that we had. And this one should total to 6, then negative 4, and then 27. The next thing that we need to do, it is for us to get the determinant of this matrix. And how do we get the determinants of this matrix? We consider the first row here. Maybe for example, if you consider 1, you multiply with this 1, you look for the other 2 by 2 matrix which is not affected by this 1, meaning that you cannot take in this row and also you cannot take it in this column. So we are going to have this one being a positive 1, then multiplied by a 2 by 2 that is not affected by this. If I hide like this, it is a 2, 5, then 5, then negative 1. And then the second, if I take this, the number that is not affected by that, it is in this, I cannot take in this and I cannot take in this, so I will be left with negative 1. Then here I have this one being a 0, 5, and then 2, negative 1, and then plus, if I consider these, the numbers that are not affected by that will be 0, 2, 2, and then 5. So now I can get the matrix of a 2 by 2 matrix. So in this case, I'm going to have positive 1, then multiplied by 2 multiplied by negative 1. Then this one is subtracted to 5 multiplied by 5. Remember the major segment and the minor segment. Then this one is minus 1. Then I have 0 multiplied by negative 1. And then minus 2 multiplied by 5. And then here I have plus. The other one is 1. Then I have 0 multiplied by 5. And then minus 2 multiplied by 2. So now I can solve this so that I have my determinant here is equals to, if I solve this one, I'm going to have 1, then negative 2 minus 25, and then minus here 0 multiplied by any number is a 0, then minus 10, and then here if I multiply this I'll have positive 1, and then I have a 0, then minus 4. So if I can carry out the operation here, I have this one being 1, negative 2 minus 25, this one becomes negative 27 here, and then I also have minus 1 here, and then 0 minus 10 becomes a minus 10 here, and then here I have plus, this one becomes plus 1, then here I have a minus 4. So if I open this bracket, I'll have my determinant here being equivalent to negative 27, then plus 10, and then minus 4. So this one is also the same as my determinant is equals to negative 27, and then a minus 4 plus 10, which gives us our dt be equivalent to negative that the 1 plus 10, so that we can have this one being minus 21. So our determinant inverse now becomes is equals to 1 all over negative 21. 1 all over negative 21 is our determinant inverse. So now we get the inverse of the matrix here. We get the inverse of the matrix. And how do we get the inverse of the matrix? We form a 6 by that is a matrix that is equivalent to those elements. If we consider the first element here, the number that is not affected by that becomes a positive 2, 5, then 5, negative 1. That is our two matrix that is not affected by the first element there. And then the other one, we have a 0, 5, then 2, negative 1. And then we have the other one, which is a 0, 2, 2, 5. And then the second, if you consider the second one, becomes 1, 1. And then we have 5, then negative 1. And then we also have 1, 1. And then we have 2, negative 1. And then the last one, we have 1, maybe 1, and then 2 and 5. And then the last one, if you consider these and hide these, the number that is not affected, remember, in this case it is 1 and then 2 and then 5 and 1. So in this case we are going to have 1, 1, 2, 5. And then if we consider the second one, we get 1, 1, 0, 5. And then the third one, we get 1, 1, 0, 2. So from here now we can be able to get, the inverse of these. That is, we get the determinant of this matrix. And how do we get the determinant of this matrix? We get the determinant of this matrix by taking what we have here and then we multiply by 8. So we are going to have this one being, we take this one to be 2 multiplied by negative 1, then we subtract 5 multiplied by 5, and then the second one, to get the matrix of it, we get 0 multiplied by negative 1, and then we subtract 2 multiplied by 5, like that. And then the third one, we take it to be 0 multiplied by 5, and then we add it to 2 multiplied by 2. So we are done with the first row. And then the second one is negative 1 multiplied by 1, and then we subtract 5 multiplied by 1. And then in this case we have 1 multiplied by negative 1, and then minus 2 multiplied by 1. And then we have 1 multiplied by 5, then minus 2 multiplied by 1. And then we have the other one, which is positive 1 multiplied by 5, and then minus 2 multiplied by 1. And then we have 1 multiplied by 5, and then minus 0 multiplied by 0 multiplied by 0 multiplied by 5 by 1, sorry, 0 multiplied by 1. And then the last one is 1 multiplied by 2, then minus, we have 1 multiplied by 1, sorry, 0 multiplied by 1. So we can compute this out so that we are left here with negative 27, then minus 10, minus 4, negative 6, negative 3, and then we have 3, 5, 2. And then here now we can transpose this, our matrix, transpose. We change the rows to columns. So in this case we are going to have negative 27, negative 6, 3, and then negative 10, negative 3, 5, and then negative 4, 3, 2, negative 3, 2. And then this one we can assign to positive signs, minus, positive, plus, minus, positive, and then minus, positive, minus, and then positive, minus, positive. Negative 27 multiplied by this becomes, this one is equivalent to negative 27, then positive 6 because of minus and a minus, and then we also left with positive 3, and then the other one is negative, positive 10 now, and then negative 3, and then we have negative 5, and then we have negative 4, negative 3, and 2, and this one now we can multiply to our inverse of the determinant, which was negative 1 over 21. And remember now this one we can also multiply with our matrix, which was 1 1 1 0 2 5, and then 2 5 negative 1. What we do on this side, we also do it on the other side of the equal sign, and when we do it on the other side, it will be also negative 1 out of 21 multiplied by negative 27, then 6 3, and then we have 10, negative 3, negative 5, and then negative 4, negative 3, and then 2, and this one we multiply it to our values, which was negative 4, and then 27 here, negative 27. So remember this one is a 3 by 3 matrix, and this one is a 3 by 1. So if we multiply here, we get a 3, we multiply, we get a 3 by 1 matrix. So if we multiply this, we get this one to be 1 out of negative 21. This one should give us, if you multiply negative 27 and 6, here you get negative 162, then plus 6 multiplied by this becomes negative 24, and then 3 multiplied by this becomes positive 81, and then 10 multiplied by 6, 10 multiplied by 6 becomes a 60, then plus negative 3 multiplied by negative 4 becomes a positive 12, and then minus negative 135, and then here we have 4 multiplied by this becomes negative 24, then plus 12, then plus 54, and this one should give us 1 out of 21 multiplied by, multiply this, get 105, and this one we get negative 63 and 42 is equals to